Hello viewers, in today's class we are going to discuss one important and conceptual integral from definite integrals involving the greatest integer function, right? So these type of integrals are very important, and let us see how we can solve these integrals with the help of substitution method, right? And moreover, we'll also apply the definition of greatest integer function, right? So let us start. So let us take this integral as I, right? So here we have 0 to pi, and cosine of the greatest integer of 2x over pi, right? So what we will do here, we'll take t is equal to 2x over pi, right? So here the appropriate substitution would be t is equal to 2x over pi. Now from here we can write the value of x as pi t over 2, right? Now let us differentiate both sides with respect to t, right? So we have dx over dt is equal to pi by 2, and the derivative of t here, so this is pi by 2 times 1, that is pi by 2, right? So now dx can be written as pi by 2 times dt. So this is the value of dx. Now see here, the limits vary from x is equal to 0 to x is equal to pi, right? So here x is equal to 0, here x is equal to pi. Now see, when x is equal to 0, the value of t is 2 by pi times 0, that is equal to 0, and here t is 2 over pi times pi. So this is pi, and pi get cancelled, so we are left with 2, right? So now when x varies from 0 to pi, t varies from 0 to 2. Now the value of I can be rewritten in terms of t as 0 to 2, and we have cos of greatest integer of t, and here we have for dx we can write pi by 2 dt. Now pi by 2 is a constant, so we can take it out from the integral sign. So we have 0 to 2 and cos of greatest integer of t, right? So now we have to solve this integral. So here we see that the limits vary from 0 to 2, right? So here we can write t is equal to 0, and here we can write t is equal to 2, right? And here we have the greatest integer of t, right? And t varies from 0 to 2. Now see, whenever we come across with the greatest integer function, we always search for the integers, right? So here we have 0 and 2. So between 0 and 2 we have the integer 1. So what we will do, we'll break this integral as a sum of two integrals. So the first one goes from 0 to 1, the second one goes from 1 to 2, right? So we can now write pi by 2, and here we have first integral is from 0 to 1, and cosine of greatest integer of t dt, and here we have 1 to 2 and cosine of greatest integer of t dt, right? So now let us first consider this integral. So here we see that the value of t varies from 0 to 1, right? From 0 to 1. So by virtue of the definition of greatest integer function, the value of greatest integer of t must be 0 when t lies between 0 and 1. So here we'll have 0, right? And when we take this one, then t varies from 1 to 2, right? And the value of greatest integer of t when t lies between 1 and 2 is 1, right? So now here we can take 1. So now this expression, it reduces to 0 to 1, and here we have cosine of 0 dt, and here we have 1 to 2 and cosine of 1 and dt, right? So viewers, we can now write this expression as I. Here we have pi by 2 and cos 0 is 1, right? Cos of 0 is 1. So we have here simply 0 to 1 dt, right? And here cos of 1 is a constant, so we can take it outside the integral, and we have here 1 to 2 and dt, right? So now we have pi by 2, and here we have the integral of dt as 1. So we have here we have t, and limits are from 0 to 1, and here we have cos of 1, and the integral of dt is t, so limits are from 1 to 2, right? So this is pi by 2, and here we have 1 minus 0, substituting the limits and taking the difference, and here we have cosine of 1, and here we have 2 minus 1, right? So now this is pi by 2, and this is 1, and here we have 1, so this is 1 plus cos of 1, right? So the value of this integral is equal to pi by 2 times 1 plus cosine of 1, right? So now it is an interesting exercise to express this result in some other form by using some trigonometry, right? So here I will express this expression in terms of other expression by using this result, that is cosine of 2 theta is equal to 2 cos square theta minus 1, right? So this is a famous result from trigonometry. So now we can write the half angle formula like this: cos of theta is 2 cos square theta over 2 minus 1, right? Now if we take theta is equal to 1 here, then we will have cos of 1, and this is 2 cos square half minus 1, right? Now take this negative sign to this side, that is minus 1. So we can now write 1 plus cos of 1 is equal to 2 cos square half, right? So see, here we have 1 plus cosine of 1. So now we can write it as pi by 2 times 2 cos square half. So here we have 2 cos square half, right? So this 2 and this 2 get cancelled. So we are left with pi times cos square of half, right? So the value of this integral can also be taken as pi times cosine square half, right?